other reason I asked you?
What?
Still didn't get the
Test
answer to
grades.
this.
You still didn't get the answer to
Me
this
and
one?
Caroline worked on it for the entire study hall, we still didn't get it.
Oh, wait a minute.
So, I don't know what I did wrong.
Studying to do. Huh?
Yeah.
I got, like, when I solved it, I had, like, x equals -2, x equals 7, x equals 3, x equals 2.
X for all of them.
Well, yeah, you can have X for everything.
That's the right number, so it's X and Y.
Except for 3, you should have gotten 3 for the other X. So the way that I did it, and everybody's not going to do this the same way, but I got Y by itself first, so your work might not match up. If you got X by itself first and your work's not going to match up, you should get the same answer. Okay? So I got the Y equals 5 minus X things. I divided everything by 2 first. You don't have to do that. You can just subtract 2X and bring it over and then divide by 2. Okay? However you did that, instead you would just have 5 minus Y instead. It would be the same thing. And then I had to take this and plug it back in for Y. If you solved for X, you would have plugged it in for X. Okay? You get it set up. I've got in parentheses, follow your PEMDAS rules. Combine this and make it, you combine your like terms so it's a little bit easier to deal with. So -x plus 7. And then you've got a square, so you have to double distribute. Right? So you got x minus 3 times x minus 3, which gets you x squared minus 6x plus 9. And then you got -x plus 7, so you got to be careful when you're double distributing. That gives you x squared minus 14x plus 49 equals 16 still. Start combining like terms. We're messing up with like things that are coming up. X squared plus x squared is not x to the 4th, right? Be careful with that stuff. All right, I'm telling you, your algebra skills, you need to be on top of your algebra skills for this exam. Absolutely 100%. Okay, we've spent a lot of time on factoring and combining things this entire year. You have to be good at it at this point. All right, so if you're a little sketchy on that, you got to put in some extra time and practice those skills because you got other things to think about on this test besides worrying about how to double distribute. All right, and not making careless mistakes while you're going through. Combine your like terms. I noticed that I could divide everything by 2 nicely and not have to deal with any fractions by doing that. So I divided everything by 2 all the way across so it'll be easier to factor. And then I subtracted my 8, brought it over, set it equal to 0, and then two numbers that multiply together to give me 21 and add together to give me -10 would be -7 and -3. So I found my x values, plugged them back into the easier equation to find my y's. If this is the Regents exam, you have 3 hours. You're at that calculator, you should be checking everything. Okay? Everything. If you can't find your mistake, if you make a mistake and you know you've made a mistake, you can't find it, leave your work and let someone decide what they can give you. But you're already going to know you got some issue there because you checked it at least. Okay? Questions? Yeah, Wendy?
How did you know that you have to like get the x? Oh, because there's x.
Yes, because you have you have to have 2 variables to have 2 equations. Now remember, some people yesterday wanted to do that like elimination technique you learned in Algebra 1. What's the issue with that? When's the only time you can do the elimination one? You know? You can only use that add down canceling thing when they're both linear. Okay, that's when we're using those. So this is a circle and a line. That's not going to work here. Okay, you need to substitute in. All right? Questions? If it's a parabola and a line, we're substituting in. Okay? Because I've seen those too. Questions on that for the Regents? All right, what other ones do we have? 12, 13, and 14? All right. Michael, what'd you get for 12? Okay. Because I know you did it.
3.
Not 11, 3. How'd you do it?
I did well, I tried to do the, what's it called? Quadratic formula.
Quadratic formula, correct. Okay, so you did the quadratic formula.
I probably had the formula wrong, but...
Well, okay, so remember, the formula is also on your reference sheet, right? Don't forget that if you do forget it. However, moving forward, you need to know the quadratic formula. You're going to be in trouble, right? So hopefully you know it. So negative b plus or minus square root b squared minus 4ac all over 2a. You have that? You think?
No, I have a different... Yeah,
Okay. So your a should have been 2. B is 3.
C is 2.
C is 2. So negate your b, so -3 plus or minus. I usually do my discriminant off to the side. We spent a lot of time on discriminants at the beginning of the year. You got 9 minus 4 times 2 and 2, calculator, that gives you -7. So square root -7, all over 2a. You got a negative underneath a radical that's up even index, right? That means you got imaginary numbers. Okay, if this was odd, then you could get an answer, but it's even index. So -3 plus or minus I square roots of 7, that's 2 times 2, all over 4. And then they just, when they wrote it, they split it up, right, into that a plus bi form. So x equals -3/4 plus or minus, this is the same as 1/4 I radical 7. So being able to manipulate things and put them in different formats is going to be also very important. Okay? And it just said a solution, right? So they didn't ask for both in this case. All right, what about 13? Yeah?
Oh.
What'd you get?
No, I got 4 and 13, but 14 I have a question.
13 should not be 4. Should be 3.
Uh,
Right? You're asking for the minimum value, minimum height. How do you find the min?
It's the midline minus the amplitude.
Correct. So 80 minus
Yes,
70,
minus
right?
And
Okay.
14, I just,
No idea?
no idea.
Okay, so 14, you got options. You can do synthetic. So x plus 3, set it equal to 0, solve, you get -3 halves, which would be what goes in the box of your synthetic. Okay, so -3 halves goes here. 4 is the coefficient. I'm missing x squared, so I need a 0 placeholder. 5, 10. Looks good there. Bring the 4 down. You can only multiply things below the line. Multiply, 2 goes in nicely, that gives you 2, so -6, add. Multiply would be -3, so +9 would give me 14. 7, -21 would give me -11. This is my remainder. This, however, you got to be careful. When you are dividing, there's one thing you always have to remember with synthetic. It's a lot quicker and it's a lot easier, but you have to remember, if you are dividing by a fraction, if this is a fraction in your box, your answer, your remainder's fine, but your answer has to be divided by 2. So this is actually not your answer. Okay? So divide everything by 2, and you get 2x, what am I, cubed squared, minus 6x plus 14. And then if you want the total divided, then you have minus 11 over 2x plus 3 for your final. Yep.
So why is it -3 over 2?
Because the value you put in here is actually your 0. So you gotta like set it equal and solve, so you know what goes in the box. Okay. Yep.
Back on 12.
12.
Yeah.
Okay.
Between 2 and 3, like I was back confused, like in choice 2 and choice 3. Like I didn't know if it was like how do you
Okay.
get 1 for it?
Because your value is not, it's not 7, it's square root of 7.
Okay, but isn't that measured?
Well, this piece is the imaginary piece. Yes, it's still an I. You still have an I. There's an I in front of that for number 1. There's still an I there.
Oh,
Still
I was thinking
imaginary.
3. I was
Right?
thinking-
No, number 3 is out. That's not really the right
Yeah.
answer, right? Number 1 is the right answer.
Correct.
Okay? Anybody want me to do this one by long division? Refresher on long. Do that. Kirsty, what's your question?
I wanted to know on number 12, like if you just did I over 4, if that's like the same thing.
I over 4 times, well, it would technically be I radical 7 all over 4.
Oh, okay.
Yep, that's the same thing. Yep. All right, so if you did this by long division, 4x cubed, you still need to hold the place value, or space. Okay, so you got to come up with what you multiply by to get to 4x cubed, right? And you want to get to exactly 4x cubed, so you're going to multiply by 2x squared. So then you multiply and you get 4x cubed, and then you multiply, you're distributing, so you get plus 6x squared. Then you got to remember to change all the signs so they cancel. So this is minus, add down, negative 6x squared, plus 5x. Now I got to get it to be negative 6x squared, so I'd have to multiply this by negative 3x. So negative 6x squared, multiply, negative 9x, change all the signs, plus, 14x, bring down the 10. Now I got to get rid of 14x, so I'd have to multiply by positive 7. So 14x plus 21, change the sign, There's your negative 11 remainder. and here's your answer. Okay? Yep.
Why you have to change the sign?
That's how you do long division. Okay? Anything else on the multiple choice? We're good. Okay, so listen, your bonus quizzes start next week. So you got 4 weeks left. You start the bonus quizzes next week. Yeah, exactly. All right? So here's what I would say to you about those bonus quizzes. If you've never come in to take a bonus quiz, if you come in every single time, if you come in once in a while, find a day for the next 4 weeks and get in here. All right? If you have 100 average and you're just like, oh, well, you know what, it doesn't matter because I have 100 average, it's not going to help me. Still get in here because it is going to help you because you're studying for the regions. You're practicing regions questions. If you're like, it never helps me, I never do good on this. Oh my God, you can't get in here fast enough because you need to practice the regions. And then you need to come see me and we need to go over what you don't understand, okay, or what you don't remember. All right? So you need to come in and spend some time. Yep.
Can we look over our test that we just got the grades for?
I'm probably not going to have time today to do that, and I got a couple of people who still need to make it up, but I will get it back to you as quickly as I can. Okay? Anything else? So please, Tuesday after school, Wednesday after school, or Thursday morning. Find a day next week, find a day the following week, find a day the following week, find a day the following week. Okay? To get in here. And then find another day if you need to come in and ask me questions about the ones you're missing. Like you've got 100, but you missed 5 questions. You still need to know how to do those 5 questions. Right? Okay? And I might be able to help you be test savvy and at least get it right another way. Okay? If you come in and ask me, like we can start playing around with your calculator so you get better with your calculator. Alright? It's crucial that you do well on multiple choice on this exam, on this Regents exam. And those are getting a lot harder than they used to be. Yep?
Can we like get some old ones, some old bonus quizzes to practice with?
Sure?
Okay.
Yep. I can do that. Come see me, I'll give you old ones. Yep.
Curve goes off, right?
What?
The curve, like,
On the Regents?
yeah.
It does. It doesn't. So this is what I would say to you guys. No one in here is going to fail this exam. It's not going to happen. I'm telling you, it's not even. It's not. You needed 27 points out of 88. That's like a 30.
Have you met me?
Yes, and you're not going to fail this exam. Okay, so that is not my concern. You're in AB. All right, you're in an enriched class. They don't call it enriched algebra 2, but it's an enriched class. Okay. So my expectation, and I do believe you can all do it, okay? I'm not blowing smoke here. I know you can do it. Is an 85 or higher, okay? Period. Is it going to take some time? Yes, an 85 or higher. You can do it. So the scale is not as generous as you move up, right? Okay? To get a 65, you need like to know nothing, all right? But to get an 85, you got to be on your game a little bit, right? Getting the 90s, you really got to be on your game, okay?
So it's hard.
So it's a hard test.
It's a hard
And the
test.
scale is not, again, not generous on the higher end. You're really getting what you're getting as you move up.
But it won't curve down, right?
Once in a while you'll see that. I don't know why they do that, but that usually happens at a higher end. I don't know why they do that, and it is what it is. I can't, yeah. I don't know why they do that. I can't speak for that. But it has happened, yes. Okay? And again, to do well, you got to be not making careless mistakes on multiple choice, not falling for not reading stuff, right?
Is it like the test we take? Like, is it half multiple choice? Is it?
It's,
Or what is
this one is, I think, well, you had it. You have the
Is-
one in
is
front
it
of you.
like
That's
that?
it. That's a
Oh.
Regents exam.
That's it?
That is the exam.
There's
That
only like
was
30
given.
questions on it.
That was given
Please
June
don't
2016. That's the
Seriously?
exam. That's it.
How many questions on? And you get 3 hours to do it?
Yes, you have 3 hours.
exactly right.
That's a
It's
long
the exact
time.
same thing. So it's 24, right?
Oh,
24
okay.
multiple choice.
Yeah.
A part 2, part 3. There's like 1 6-pointer, right?
Yeah, but a 6-point question's like 10 questions in one.
Right. It's gonna have a lot going on, right?
So that's really like not one.
All right, so get in here. That's the bottom line. Get in here, right? You've got the practice region stuff. We haven't done statistics, and there are a lot of questions on statistics. They love statistics. Ugh. Okay. All right, what do we got going on probability? Is there anything? Yesterday I feel it was fairly easy. Yep, what do you got?
So like, what's the difference between, or how are you supposed to find experimental probability?
Experimental, you need to be given data.
Okay.
Okay, so like you've got this table and these are the results. Theoretical is more like what you've done in the past, more like thinking about what's going on.
Oh.
You know, like how many outcomes do I have? If I'm flipping a coin, I have 2 possible outcomes, and what I want, there's only 1 possibility because I only want heads. You know what I mean? So it's a 1 out of 2. It's not actually me doing the data, because if I actually flip the coin 10 times like we did in class yesterday, most people, or we rolled a die, but most people are not going to get half heads and half tails when they flip it 10 times, right? Because it's experimental. Okay?
Like, for number 4,
On the
on
homework?
page 12,
This one?
yeah, like, I just didn't get what I was supposed to do, like, at all.
So this is you got to figure out how many total times they rolled the cubes, right? And then what do they want? The experimental probability of rolling each number. Okay, so what was the chance that you were going to roll a 1? 42 out of the total.
Yeah, 42 out of 260.
Okay, so that's your chance.
Okay.
Okay? Now, you could leave it, like I've been writing them as decimals and as percents and back and forth. You don't need to do that on your tests. Unless the direction specifically says what percent, then you have to put it in a percent. You know what I mean? Like round to the nearest hundredth, then you've got to make sure you're rounding to the nearest hundredth. If they just say what's the probability, and the easiest way for you to think about it is 10 over 20, then leave it like that, 10 over 20, done. Okay, I am only going and doing all those numbers over and over because I know you need to be comfortable that they're all the same thing, okay? Because if I now give you a problem 2 days from now and I don't give it to you as 6 over 20, but I give it to you as whatever, 0.6 or whatever, 6 over 10, I give you as 0.6, you gotta understand that's the same thing. Okay? And then it's all related.
I think that was just overthinking.
Yeah. You're okay though?
Yeah.
Okay. Anything else? We're moving on today. You got a lot of vocab coming at you today, all right, that you need to stay on top of. Today's the first day where it's going to start, you're going to, again, people were asking me earlier, is it hard? I would say on a daily basis, day to day, when you know what you are looking to try to accomplish, no, it's not that hard, okay? But as long as you stay on the vocab. The problem is, once we start mixing everything together when you go to take your test, right? Now you got to be able to say, okay, I know I do this here, and I do that there, and I do, right? You understand what I'm saying? So you've got to stay on top of the vocab, and some of the wording on some of the problems gets a little weird. Okay? So just please make sure you're not just going through on a nightly basis and not thinking about what you're doing. All right? Pay attention to vocab and actually ask yourself the questions. Okay? All right, let's move, because we spent a lot of time. All right, so first vocab we're talking about is independent versus dependent. Okay? So we say events are independent when, like I'm flipping a coin, right? I go to flip a coin. I flip it the first time, I'm going to flip it twice. I flip it the first time, and I want to get a head and a head. Okay, that's what I want to happen. I want to know what's my chance that I'm going to get a head the first time I flip it and a head the second time I flip it. So I go to flip the coin, right? And I get a head. Okay? When I go to flip the coin the second time, what I get the first time make any difference in terms of what's going to happen the second time I flip it? No, it has no impact whatsoever, correct? It's not going to change the probability the second time I flip it. Still 1/2. Okay? Those are independent events. All right? Dependent events are when what you get the first time affects what's going to happen in the future. Okay? On your next roll or event or whatever it is. Like, remember the keychain one we did the other day, right? And the kid reaches in the bag and you want the keychain, and he reaches in, and he had, I don't remember what it was, like 1 out of 6 chance of getting a keychain, right? And he didn't get it. But now the kid who goes to pick the next time has a better chance of getting the keychain, correct? Because those were dependent events. What this kid's probability now affected the next probability. You guys kind of follow me there? So those are dependent events. Okay? In either case, you are trying to get something and something else. All right? And you want your chances of that happening. Okay? So, read these. Are the outcomes of each trial dependent or independent? I roll a die and then I spin a spinner. Would those be independent or dependent events, everybody?
Or independent.
Independent, right? Does one affect the other one? No. So we say those are independent. I don't know other flashcards, but you pick 2 flashcards from a stack of 30 flashcards. So I pick a flashcard, right? Okay, whatever my chance. Let's say I want a red flashcard. I don't know what they are, but the red. I pick it, and now I want to pick another one. I picked another one. Will it affect me picking the first one affect what happens when I go to pick the second one? What my chances of getting a red the second time? Yes, because why?
There's less.
Because I took one out, so there's less cards here, which means my chance goes up, right? Assuming this isn't what I wanted. Probably goes up. So these are dependent events. They depend on each other. Okay? You select a coin at random from your pocket. You replace the coin, and you select another coin. Independent or dependent? Independent. Now, if I had taken the coin and put it on the table, then shook everything up and reached out, would that be independent or dependent? Dependent. You guys following that? Alright, so if events are independent, okay, independent events, roll a die, flip a coin, then if you want to know the probability of getting a head and then followed by a 1 on the roll I do, right, then I just have to take the probability of getting a head, which is a half, and multiply it by the probability of getting a 1, which is 1 out of 6. And that will be the probability, the chance, that will happen in that order. Yep?
I have a question. Are you recording this?
Yeah, it's recorded.
Oh, okay.
Say hi to everyone.
Hi.
Oh, you missing people?
They heard like a speech and like.
You're gonna say hello?
I'll try to be smart.
Okay, you gonna be smart for them?
Wait, did you have that on for like a speech in the beginning?
Oh yeah, they got it all.
Uh-huh.
They can fast forward through all that. Alright, so a bag contains 6 black marbles, 9 blue marbles, 4 yellow, 2 green. A marble is selected, replaced, and a second marble is selected. Find the probability of selecting a black marble, then a yellow. So again, if I write P of something, I'm saying I'm finding the probability, correct? Chance. So probability that I'm going to get a black marble first, and, let's underline and, because the word and is related to independent, dependent. Okay? Probability of black, and then a yellow, followed by a yellow. So is this an independent event, or is it a dependent event?
Independent.
Independent. What's the key word in this that makes it independent? Replaced. Which means everything you pick it, then you throw it back in, and you pick again. Okay, so this is an independent event. So then based off our definition, I really just want to know what's the probability of getting a black marble? What's the chance that I'm going to get a black marble when I pick? Katie?
9 out of 21.
I get 9. That's blue.
Oh, sorry. 6 out of 29.
6 out of how many? I don't
Or
know.
21.
21? Okay.
Sorry, I'm
It's okay. 6 out of 21. And then what's the probability that I'm going to get a yellow? Yeah. 4 out of 21. And if I want to know the probability of me getting both in that particular order, then I'm going to take 6 out of 21 and I'm going to multiply it by 4 out of 21. Which gives me 24 out of whatever that is, 441. So again, if this was a test question or a quiz question, you could stop right there and there's my answer, right? But I'm just writing them as decimals and percents so we get an idea and a feel for what the chances are here. So this is decimal-wise 0.054421786687, which is approximately 5.4%, not a super high chance of that happening, which seems logical. It would be kind of difficult out of 21 marbles to pick a black followed by a yellow in that specific order. Now, does it make sense to you that if I was okay with just getting a black and a yellow at any time, that my chances would go up a little bit? Right? Like if I don't care whether I get a black first, I could get a black or a yellow first as long as I got the other one the second time, that it would at least be a little bit better. Are you guys okay with that? So this is specifically saying in that order. Okay?
I have a question. It doesn't really have to do with this, but when I hit my fraction, like how do I do fraction to decimal?
Fraction to decimal?
Or, yeah.
Divide. I just, if I want
Okay.
6
Like, I don't know how to
divided by
do
9.
fraction to decimal.
Fraction to decimal?
Or decimal to
It might be
fraction.
under
It's
math.
alpha F1, and then number
Like
4 is
fourth
fraction
one down?
decimal. And then it's a decimal, it doesn't have
Thank you.
Okay. All right, any questions on that? All right, so dependent. Let's talk dependent here. Dependent, I want this and this to happen, but it's a dependent event, okay? It's still going to be multiplication, and you're still going to figure out the probability of the first one happening, but then you've got to base the probability off of what happened in the first one to get the probability of the second one. okay, which you've done. This is not going to be like a surprise to you. Cindy randomly draws 3 cards from a standard deck, one at a time, without replacement. Okay, that's the key, correct? Because that makes these what? Dependent. What you do the first time is going to affect the probability of going on, right? So these are dependent events. Okay, so I want the probability that she's going to pick a 2, and then, so 2 and a 5, and then not a 5. What's the chance that that's going to happen for her, right? So what this says is, okay, well, if you want to figure out the probability of a 2 and then a 5 and then not a 5, you really just need to know the probability of getting a 2. What's the probability of getting a 2? 4 out of 52. So here's where we got to know our card stuff, right? 4 out of 52 chance. Okay, but it's without replacement. So when I go to pick the 5, it's been impacted, correct? Okay, how has it been impacted? How many cards are there now? 51. And what's my chance of getting a 5 out of those 51 cards?
4 out of 50.
4 out of 51. Are we okay with that? Because I did not replace and put the 2 back in, right? So that's why it's dependent. And then the last one, I want to know what's my chance I want to not get a 5. I don't want to get a 5. Well, how many cards are there left? 50. Okay? And I don't want to get a 5. How can I figure out what my chance is? Alex?
Well, just subtract 3 from 50.
From 50, right? There's still 3 5s in there. Do you guys agree with that? Still 3 5s in there. There's 1 5 that's sitting on the side that's not part of that. And I don't want to get one of those 3 5s, which means there has to be 47 cards I would want. Okay, so 47 out of 50. If I want to know my chances of all of these happening, this and this and this, and I do what? I multiply, correct? Then I'm going to multiply these together. So 4 out of 52 times 4 out of 51 times 47 out of 50. Whatever that is. I think you get a decimal in your calculator. We did this earlier. If you want to know what the fraction is, just multiply straight across. I don't think it's going to give you a fraction in your calculator. It doesn't like it for some reason. If I multiply straight across, I got 752 on top, and multiply straight across on the bottom, I get 132,600.
Yeah,
And decimal wise, you're getting 0.00567119116,
yeah.
right? Which is approximately what? What percent is this? Approximately. So 0.6, not even 1%, less than 1% of a chance of this happening. Okay? So approximately 0.6% or less than 1% chance. Not very probable. Yep.
When they say like you have a 1 in 10 chance or 1 in 100, or whatever it is, how would you translate like 752 out of 132,000 to a 1 in something? Is there like, if you divide the bottom by 752, that's your 1 in something chance?
So you're, well, yeah, I mean, if it's a 1 in 3 chance, it's a 1/3 chance. You know what I'm saying?
I might rethink this.
So it would have to be like a 1 in, right.
So
So it's so you'd have to be able to get it to a 1 out of 10. I mean, it might be like a fraction, like over a fraction.
I'm just thinking of what the fraction would you have it be a
1 in whatever.
0.6%
Like,
chance.
Like you divide the bottom by what, 752?
132,600 over 752.
What do you say?
It would be 1 in 132,600 over 752.
1
Wait,
in,
that doesn't.
Just forget.
That's a legitimate number, because that's a fraction.
But where are you getting that from?
dividing both by 752.
Okay, that's all I
So
had.
you got a 1
So
on
it's a
top.
1 in 176, whatever.
Okay. All right. So can you just read both of these and decide whether they're independent or dependent? And then we'll do the work together. Read and decide, independent or dependent. All right, so if Jane is flying from Albany, Chicago, her 90% chance that she'll be on time. Same day, it is raining in Denver, the chance of rain is 50%. What's the probability Jane, her flight will be on time, and then it will rain in Denver? So really, you just want to look at the events. Are they independent or dependent events? Independent. They do not impact each other at all, okay? They are independent events. And if they are independent events and you want the probability of being on time and it's going to rain in Denver, I'm just using T for on time and R for rain, then how am I going to figure out what that chance is of them both happening? Yes.
You just multiply.
You multiply. So what am I multiplying?
0.9 times.
So I could just go decimals here, right? So I could go 0.9 times 0.5 or 0.45, or there is a 45% chance of both of those happening on the same day. Questions there? All right, what about the next one? Independent or dependent? You're going to pick two stuffies. Dependent, right? Because once you pick the first one, then it changes your probability of getting the second one. So probability of two stuffies. I don't know if that's how you spell it, stuffies, but that's how I'm spelling it. Stuffy. So cute. Little stuffy. All right.
Did Caroline used to say stuffy?
I don't know. Probably not. I probably said it. Don't remember. Probability of two stuffies. All right, so what's the probability I get one the first time?
8.
8 out of, not out of 12.
23.
Oh, sorry.
Yeah.
Yes, 12.
Oh.
Sorry,
yeah.
my bad. You're right. 8 out of 12. 12, oh no, that's toys.
23. It's fine.
It's 23. That's just toys in the bin.
Shucks.
Madison was right.
You know, that could be randomly different.
Well, I'll get used to that because these problems are nicely worded often. All right, so 8 out of 23. And what's my chance I'm going to get stuffy the second time? 7 out of 22 because they're dependent, right? Okay, so 56 out of 506. Which again, if this was a test or a quiz, you could leave it like that because the directions don't say nearest percent or anything, right? So you could just be done. But we're just practicing. So 0.11067. 19368. Or better feel for it, about 11.1% chance of picking the two stuffies. Questions there? All right, so these are ands. We want both to happen. Okay? Independent and dependent are related to and. Both things are happening. We now need to talk about or and the vocab that goes along with or. Okay? So or. I want this or this to happen. Okay? So you are mutually exclusive if they don't overlap at all. Remember Venn diagrams? Okay, so I want this or that. I want to get a 2. I got a deck of cards. I want to get a 2 or a 4. I don't care which one, right? I'll take any 2 or any 4. Totally separate from each other, correct? So they are mutually exclusive. Okay, and if I want to know the total chance that's going to happen, it's how many 2s, right? How many 4s I have, and then that's out of the total number of cards. You guys agree with that? Okay, and you're adding it together. All right. So, a standard 6-sided die is being rolled. Find each probability. The probability of a 3 or a 5. Okay, so again, I know you can do this in your head without having to worry about adding and all that stuff, because you're just like, there's a 3 and there's a 5, there's 2, and that would be 2 out of 6. I get that. And for these, that's fine. But when you get to some of the ones that are a little bit more confusing, you got to understand how to do it. Okay? So what we're saying is, you can think in your head, or you can just say, what's the chance I get a 3? 1 out of 6. What's the chance I get a 5 individually by itself? 1 out of 6. And because these are mutually exclusive, right, and I'll take either one, I would add 1/6 plus 1/6, and that gives me 2/6 or 1/3. Okay, and then you can do your decimals and your percents and whatever else you need. What's the probability of getting less than 3 or a 6? Okay, let's just treat it as if can't think of it in our head by ourselves here. So what's the probability that you're going to get less than a 3 when you roll? 2 out of 6. You'll take a 1 or a 2, right? And I'm leaving it as 6 because I'm going to need a common denominator when I add anyways, right? So why reduce? What's the probability of getting a 6?
1/6.
1/6. I'll take either or, right? So 2/6 plus 1/6 tells me I got a 3/6 chance, or a half, or 50%, or 0.5. Okay, which again makes sense to you if you just think about a die. All right? Questions on that? Okay. Not mutually exclusive means they overlap each other. So if I try to do it this way, where I figure out the probability of one and figure out the probability of the other one, there's some overlap I'm missing here, or I've covered two twice. So I need to subtract and get rid of the repeats. Okay, so here's what I mean by that. This would be not mutually exclusive. Find the probability of picking a 2 or a diamond from a standard deck of cards. Okay, so this would be not mutually exclusive. What's the chance I get a 2? If I only think about 2s, what's the chance I get a 2? 4 out of 52. And if I only think about diamonds, what's the chance I get a diamond? 13 out of 52. But what you have to realize is that's great if these were mutually exclusive, 2 or diamond. I would just say 4 out of 52 plus 13 out of 52, and I'd be done with it, right? That would be my answer. However, if you think about this logically, isn't one of these 13 diamonds a 2? And one of these 4 2s is the diamond, correct? So I've counted it twice when I've done this, right? Think of it as a Venn diagram. Here's all my diamonds. Here's all my 2s. And right here in the middle is the 2 of diamonds, correct? Which is in both. So I need to subtract out the chance of getting that. Okay? So minus what? 1 out of 52. Because otherwise I'm repeating it. I'm doing it twice. Okay? So then my chance of getting a 2 or a diamond becomes 16 out of 52. Because they are not mutually exclusive. Alright? They have some overlap. You have a both going. Okay? This one, you guys are going to be okay with because you can picture the cards and it makes sense to you. Then they throw this at you. You have an insurance company, typically tries to sell different policies to the same customers. 56% of their customers have car insurance policies with them. 48% of their customers have home insurance and 18% have both. Okay? Now looking at these numbers just overall, you got 56% and you've got 98%. When I add those together, you're already over 100%, correct? Why? Because over here in people who have car insurance, there's also some people that have homeowners, right? And here's all the 18% that have both. So see where the overlap's coming in? Okay? So you want to find the probability that they have at least one of these policies. So they either have homeowners or right? Homeowners or car insurance or both. Correct? So what's the probability? If I want to know probability of at least one policy, these are not mutually exclusive. So I want to know the chance, if they're not mutually exclusive, what's my chance that I pick someone who has car insurance? Well, 0.56 or 56 out of 100, however you want to write it. Okay? That doesn't mean there's 100 people, but it's 56% of whatever number of people there are. Plus, have the people, or percentage of people who have policies, 48%, and then what do I have to get rid of? The both, right? The overlap, the part of the Venn diagram in the middle. Okay, so minus my 18%. And that's going to tell me the probability of at least one policy. And that was what? 86? So 0.86 or 86% of the people have at least one policy. That means 86% of people have at least car insurance, or they have a home, or they have both, right? Okay, so find the probability they'd have neither. They're a customer, but they have boat insurance. I don't know. Right? What's the chance of that? How would I find that?
Would you just take 56 plus 48, or 0.56 plus 0.48?
Well, that again would include people who have at least one, right? I want nothing. I want them to have nothing. Yeah?
100 minus 86.
Yeah, 100 minus 86 or 1 minus 0.86, because this covers everything else, right? At least one, so 1 minus 0.86 or 14%. I'm gonna try to squeeze in this last one here. You have 100 students, 42 are taking French, 26 are taking statistics, 8 are taking both. So is there overlap? Yes. And you want to know the probability of them taking or. The word or tells me I'm talking mutually exclusive or not mutually exclusive, and I am adding, correct? Versus and, okay? So this would be not mutually exclusive, which means I know I got to add my probabilities and then I got to do what? Subtract anything that overlaps, the both, right? So the probability that you're going to pick somebody who takes French or statistics, you would have what? 42 out of 100. You can do decimal if you want, right? It's not going to matter. 42 out of 100 students take French, plus the 26 out of 100 students who take statistics, and then do what? Subtract the 8 that do both, right? That you've already counted in these other groups. Don't want to repeat twice. And that got me 60 out of 100, or a 60% chance. Be careful if you use decimals, because people like to write 0.8 for 8%. Is 0.8 8%? No, that's 80%. So if you're going to use decimals, be careful. Do this homework, read carefully, stay up on the vocab.